Hi everyone. In the last lecture, we have discussed factors affecting on the adsorption, characteristics of the adsorption, and the types of the adsorption. In this lecture, we are going to discuss adsorption isotherm. So here, adsorption isotherm. So definition of the adsorption isotherm, or what is meant by adsorption isotherm. So adsorption isotherm, it is the relation between amount of substance adsorbed by adsorbent and equilibrium pressure or concentration at constant temperature is called as an adsorption isotherm. So here, when we consider the adsorption isotherm, it is a simple relation between the amount of substance adsorbed by the adsorbent and the equilibrium pressure or the concentration at constant temperature. So here adsorption isotherm, it is classified into the two types. So classification of the adsorption isotherm. So the first type is Freundlich adsorption isotherm, and the second one is the Langmuir adsorption isotherm. So here in this lecture we are going to discuss the Freundlich adsorption isotherm, and in the next lecture we are going to discuss Langmuir adsorption isotherm. So here Freundlich adsorption isotherm, it gives a relationship between amounts of substance adsorbed, that is the extent of adsorption, with pressure and concentration at constant temperature. Then when we consider the Langmuir adsorption isotherm, so Langmuir adsorption isotherm describes the fraction of the surface covered by adsorbate molecules at constant temperature and pressure of adsorbate. So let us discuss one by one. In today's lecture, we are going to discuss only Freundlich adsorption isotherm. So Freundlich adsorption isotherm, it is an empirical equation for the variation of extent of adsorption with pressure at constant temperature. It was proposed by the Freundlich in 1907, and it is known as the Freundlich adsorption isotherm. So friends, here Freundlich adsorption isotherm, it is an empirical equation for the variation of the extent of adsorption with pressure at constant temperature. So here mathematically the Freundlich adsorption isotherm, it is expressed as by equation x by m is equal to k into p raised to 1 upon n. This is the equation number 1. So here this is the mathematical equation for the Freundlich adsorption isotherm. In this equation, x is the mass of the gas adsorbed, where m is the mass of the adsorbent. Here x by m is the amount of gas adsorbed per unit mass of the adsorbent. P is the equilibrium pressure, and here in this equation this k and n, these two are the empirical constant. Friends, this k and n are the empirical constant, and they depends on nature of the adsorbate as well as on temperature. It is found that the value of n, that is n is the empirical constant, so value of the n, it is always greater than 1. Hence, amount of the adsorbed gas increases less rapidly than the pressure. This adsorption isotherm has no theoretical importance. It holds only up to the medium pressure of the gases. So here this is the equation for the gas. Then here when we consider the case of the adsorption of solute from the solution, the equation 1 can be written as, so x by m is equal to k c raised to 1 upon n. This is the equation number 2. Here c is the equilibrium concentration of adsorbed substance, that is adsorbate in a solution. X is the mass of the solute adsorbed. M is the mass of the adsorbent, and here x by m is the amount of solute adsorbed per unit mass of the adsorbent, and k and n are the empirical constant. So here this is the equation for the Freundlich adsorption isotherm for the adsorption of the solute from the solution. Then let us consider the Freundlich adsorption isotherm showing the plot of mass of adsorbed gas per unit mass of the adsorbent against the pressure. So here the graph of the x by m versus p. So here the graph is divided into the three parts. So here we are going to consider the graph at low pressure, moderate pressure and at high pressure. So here the above graph is divided into three parts. So here at low pressure, so here this is at low pressure, the amount of the gas adsorbed per unit mass of the adsorbent is directly proportional to the pressure. So this x by m, it is directly x by m is directly proportional to p, and then this can be written as x by m is equal to k into p. So here number 2, and at intermediate pressure, the amount of the gas adsorbed per unit mass of the adsorbent increases very slowly, and here we can say that x by m is directly proportional to p raised to 1 upon n. So here at moderate or at intermediate pressure, this x by m is directly proportional to p raised to 1 upon n, and this can be written as x by m is equal to k into p raised to 1 upon n, where k is the constant. Then at high pressure, the amount of the gas adsorbed per unit mass of the adsorbent remains constant. That is, the shape is approximately parabolic shape. So here at high pressure, the amount of the gas adsorbed per unit mass of the adsorbent, it remain constant. So here x by m is equal to k. So at high pressure. So here this is the graph of x by m versus p. Then from equation 1, so here we can write x by m is equal to k into p raised to 1 upon m. This is the mathematical equation from the Freundlich adsorption isotherm. So here taking the log of the both side. So here when we take the log of the both side, this equation can be written as log of x by m is equal to log k plus 1 upon n log p. This is the form of the equation y is equal to mx plus c. So here y is equal to log of x by m, and here c is equal to log k, while mx is equal to 1 upon n log p. M is the slope of the line and slope is equal to 1 upon n, and here x, the value of the x is log of p. All of you know that when we have the equation of the straight line, that is y is equal to mx plus c, we always plot the graph of y versus x. Here the value of the y is log upon x by m and the value of the x is log p. So here let us consider the graph of log of x by m versus log p. So here this is the graph. So here when we consider the graph of log of x by m versus log of p, so here this is the nature of the graph, and here nature of the graph is straight line, and here when we calculate the slope of this line, slope is equal to 1 upon n. So here when we plot the graph of log of x by m versus log of p, here from this graph we can find out the value of the n. Then here the intercept is equal to log k. So here log k is equal to intercept. So here from the intercept again we can find out the value of the k. So here in the Freundlich adsorption isotherm, n and k are the empirical constant, and the value of the empirical constants, that is the value of the k and n, are calculated by plotting the graph of log of x by m versus log of p. So here Freundlich adsorption isotherm, it is applicable to the moderate range of pressure or concentration, and it fails at high pressure or the concentration. So friends, this is about the Freundlich adsorption isotherm. Thank you.